File format types. There are many types, hundreds of types of file formats. I just want to go through and talk briefly about a few so that you are aware of them and you kind of understand how they work. Their benefits, the advantages of certain file types, and the disadvantages. So before we talk specific types, let's just talk about what we classify a file type. We call them either a native file format or a non-native file format. So when I talk about creating a graphic, maybe we're working in, say, Adobe Photoshop, and you create a Adobe Photoshop image, you're saving that Photoshop file as a .psd. That's the extension for a Photoshop file. That would be the native file format for Photoshop. Moving on to Illustrator. We'll work with Adobe Illustrator. You create an illustration and I say, I want you to save it as the native file format from Illustrator. So in that case, it would be what's called a .ai, that's the extension for an Illustrator file. So a native file format is what is created for within a specific program. And in order for it to be recognized by another software, it may need to be converted. The exception is with the Adobe family. So yes, you can open an Illustrator file in Photoshop, and reverse, you can open a Photoshop file in Illustrator. You can open an Illustrator file in Adobe Acrobat. But in most cases, you are going to do some sort of conversion of that native file format into a non-native format. So the non-native is what happens when you do, say, a save as, and you change that extension, or an export. In order to bring in one of these files, you would probably do an import, or depending on the software, it might be a place, an insert, a get picture, however that software terms that task. So if I were in Photoshop again, and I created something, an image in Photoshop, and I saved it as a JPEG, because JPEGs I know are more flexible, and I can open it in multiple programs, I can use it in multiple places. So what I just did is I made a non-native file format when I made the JPEG. Okay, so we're going to talk about file extensions here, or what's called a file name extension, depending on how you term it. Basically, that extension is the suffix at the end of a computer file. Now, I do want to note, sometimes the view may be set in your preferences where you do not see that extension. I know on a Mac that can happen. So it is best to make sure that those extensions are on. You can see that with the file name because it will give you a lot of information as to what type of a file that is. So that file extension, we're going to talk about those as we talk about these different file types. Like I said, it comes after that period, the file name, dot, and then that extension. And it's typically 2 to 4 characters long. I would say generally we're looking at 3 characters. So if you've ever opened a document or viewed a picture, you probably noticed that they have those, .jpg for JPEG. Let's start with JPEG. Okay, so JPEG, the JPEG stands for Joint Photographic Experts Group, and that basically was the technical group that developed it. And it is the most popular, it's the most widely accepted image format that's used on the web. And since it was developed in 1994, it's really been considered the standard for, like I mentioned, web, especially for quick previews. It's a compression format. It crams together the information, if that's a good way of saying it. It's called lossy compression, meaning it actually discards data. That's why we say lossy compression. Basically, it identifies the color information on a pixel. It chooses to discard that extra data that's not essential to the display of the image. So JPEG images do have what we call a sliding scale of compression. And that allows us to decrease that file size tremendously. However, you know what happens if we're decreasing the file size? We are throwing away information. So we may say, let's keep information on pixel 1, pixel 2, and pixel 3, but pixel 4, let's just throw it away. Pixel 5, pixel 6, and pixel 7, we'll keep that information. Pixel 8, we'll just throw it away. Okay, so when we do that, yes, we are decreasing that file size, but we are increasing what we're going to call artifacts or pixelization. Maybe you've heard that term before. The more the image is compressed, the more pixelized it's going to become. So more compression does equal smaller file size, but that also means lower image quality. Less compression equals a larger file size and better image quality. So it's really a kind of a juggling act of how much information do you want to throw away? How big do you want your file size to be? And we play that game a lot with images on the web. We don't want to have ginormous images that may take a second to load. We want things to be quick. However, if we want them to be quick, the quality may have to be sacrificed in order to have a smaller file size. JPEGs are good for continuous tone images like photography because they can have kind of a high range of color. So there are other formats that we're going to talk about here in a minute that what we call it banding. What happens is colors they almost look like they're in strips. Think of banding as being kind of chunks of color. JPEGs are really good at making continuous smooth color transitions. But like I mentioned, you compress it. If you zoom in, you're going to find those artifacts. Because of that, the way that it's compressed, the way that the data has been discarded and been kind of, pushed together to make it be small. Overall, pros of JPEG, they can be what we call 24-bit color, which means they can handle millions of color. They are typically have rich color, great for photographs. They are used widely. It's probably one of the more standard formats that we see out there, and it's compatible with most operating systems, meaning Mac, PC. They work both platforms. The cons of JPEGs, they do tend to discard information. They discard a lot of data when it's compressed, which obviously leads to those artifacts. They cannot be animated. They do not support transparency. And they do not support layers. So remember that you cannot take your Photoshop file that you spent hours and hours building this awesome image, this awesome graphic that has multiple layers. You save it as a JPEG, it smashes it all into one layer, and there you can't go back and edit. Once it's compressed, smashed, you can't undo it. So that's something to remember is that, JPEGs just become a picture. Let's move on to a PNG. PNG stands for Portable Network Graphic Format. It was actually created in '94 as a replacement to a GIF that we'll talk about here in a second because a PNG didn't require a patent license like a GIF did in the past. So PNG has been approved as a standard since around '96, specifically designed for the web. So it is really a superior version of a GIF. Like I said, we'll talk about GIFs here in a minute. PNGs can support 24-bit color and also transparency. So we can use a PNG for color images, for grayscale images, both with or without alpha channels. So alpha channels where we get the transparency. PNGs are not specifically designed for print. So they're better for an image that's going to stay in an online format. So PNGs are really better at compression than a JPEG. Pros of the PNG, it's a less compression. So that means it does not lose quality or detail after being compressed. So in a lot of ways, it's better than a JPEG in that manner. It's also better than a GIF because of what it can do. It often creates a smaller file size, and it is really a better alternative for supporting transparency. So you would use a PNG if you need high quality, transparent web graphics. So like I mentioned, they have that variable alpha channel that can have really any degree of transparency. Plus, it has greater color depth than some of the other options, which gives you a more vibrant image. The cons of PNGs, they're really not good for large images because they will tend to generate a very large file, sometimes creating a larger file than a JPEG. A PNG cannot be animated, and there may be some older web browsers that do not support a PNG. Next up is the TIFF, Tagged Image File Format. So this is a raster, or we call it bitmapped file format. So in this case, we talk about bitmapped, as we did earlier, means with the raster graphic or rows of pixels. So TIFF was created back in the day, it's been around for a while, by Aldus for desktop publishing. So in 2009, actually, it was transferred to the control of Adobe Systems, and currently it's maintained by Adobe. And it was really developed as an exchange document between applications and computer platforms. So if someone was working on a Mac and they had to share it with someone working on a PC, it could go back and forth. So it was at one point, one of the most universally used formats because of that. TIFF was really created for scanning images because it did produce a high quality print graphic for scans and professional photos. We don't see a whole lot of TIFFs out there anymore because of just the advancement with some of these other formats. TIFF supports what's called LZW compression, which is a lossless, meaning there's no quality lost. So in this case, the compression happens by saying, okay, pixel 1, 2, 3, 4, 5. All of those pixels from 1 to 5 are white. So rather than remembering pixel 1 is white, pixel 2 is white, pixel 3 is white, and so on, it says my range from 1 to 5 is white. So it does not throw out that information. Rather, it just kind of evaluates and says, okay, this block of pixels, this color, that's all you need to remember is the block, not the individual pixel. We can use color modes of CMYK, RGB, grayscale with a TIFF. So overall pros of a TIFF, it's pretty flexible. It supports the compression. It's typically a high quality image, so all of the color and data information are stored with it. Cool thing is that now TIFFs actually can support layers. The cons of TIFF, that it does produce a fairly large file size, which will then basically means a longer transfer time, slow loading time, that type of thing. So typically you do not use TIFFs for web graphics. It's more for anything heading towards print. Next up is the GIF. So this one stands for Graphics Interchange Format. The .gif is the extension. Sometimes people call it a graphic image file. It was created in 1987 by CompuServe Online Services as a window platform. So it's commonly used for any kind of graphic that would be uploaded or online. Primarily it's for like clip art or text. So we call it kind of like for flat images. So the little debate out there is how to say it. So I was taught almost 30 years ago to say GIF, like the peanut butter. The creator of GIF calls it GIF, like the peanut butter. But a lot of the world says GIF because they say it's graphics interchange format, it's a graphics image file, GA for graphics. So I think out in industry we come to terms that some people will call it GIF, some people will call it GIF, and we just know either way, we know what it is. Okay, so it was used as an exchange graphic between different types of platforms back in the day. It is only limited to what we call an 8-bit palette, which means we can only have 256 colors. So my graphic can only have 256 colors. It can have less, but it can't have more. And so that's how we get a smaller file size. And the file sizes are fairly small when we especially compare it to JPEGs. What it uses is an index color mode, and that's something that you may learn in a color theory class at some point. It's just a way of actually just reducing it to 256 colors. So it is a format that also is used for animation. And this is actually due to the explosion of mobile platforms. Okay, so one thing with GIF is that it has what's called an interlacing feature. Some of these formats do have that. So it gives the illusion of a very fast, super speedy loaded graphic. But what happens is that it loads the first time when it loads, it looks maybe a little blurry, little fuzzy. But as more data is downloaded, the image becomes more defined until all of that data has been downloaded and it's a much more crisp image. You maybe have seen that online, maybe even on your mobile platform where on your phone you might have something that comes up kind of blurry and then in a minute it makes it more crisp. So that's called interlacing. GIFs can support transparency. So that is one of the huge pros of GIFs. Along with the small animation effects that it can do, and it's considered lossless quality. So even though I can only have 256 colors, it's not throwing information away. Again, it's remembering kind of that regions of flat color and remembering a region rather than individual pixels. So a GIF is really great for images, illustrations especially, that have limited color. So cons of GIFs, again, only supports 256 colors. It is the oldest format on the web, so it has existed since 1989. It's been around for a while. Really hasn't been updated much since. So a lot of times, we might look at a different format instead of a GIF. You do not want to use a GIF for any kind of photographic image. It does not support that continuous tone, and it does not support layers. All right, so let's move on. So this is kind of our, the raster group. I want to talk about some vector file types here, and we'll start with PDF. So PDF is portable document format. Again, PDF is very versatile in that it can be viewed in any type of computer operating system. And the documents are typically, we can say, almost always displayed correctly, no matter of the device, the application, operating system, or web browser, because things are embedded. So we view PDFs with Acrobat Reader. That's the viewer, and that's free for anybody. In fact, well over 90, I think it's actually pushing over 95%, if not even higher, of all computers have Acrobat Reader on them. So it's very universal. And it does have a powerful vector graphics foundation. It can display raster graphics as well as spreadsheets. I mean, it's a lot of opportunity in a PDF, I should say. So the cool thing, like I mentioned, it embeds. So the fonts are embedded. So whatever font you use in a PDF will appear on the user, whoever the viewer of the PDF is. So you don't end up with missing fonts. The vectors, the links, the images, all of those appear. We edit a PDF with Adobe Acrobat DC. It's part of the Adobe Creative Suite that we have. We can open a PDF in Adobe Illustrator, for some potential editing as well. We don't want to use a PDF to edit. If you need to edit your design, you're not going to start with the PDF. You're going to go back and start with the native file format, whether that's an Illustrator or an InDesign document. So you don't intend to edit a PDF, and it really is print files or web-based documents. SVG, another vector graphic. SVG stands for Scalable Vector Graphics, and it's fairly new in terms of file format options. So this is probably our newest one out there. It was created in 2001 by the World Wide Web Consortium, which is as a standard for web graphics. And it was designed specifically to work with HTML, CSS, JavaScript, etc. Okay, so it's an XML vector-based image format for two-dimensional graphics. Vector files for web, basically. It does support interactivity, it does support animation, and it's often created with drawing software. So we're going to look at it with Adobe Illustrator. Last vector format here to talk about is the EPS. This is another kind of older format out there, Encapsulated PostScript. So this vector file format is used primarily for vector images, mostly illustrations. The cool thing about an EPS is that it prints at the resolution of the printer. So your limitation is how well your printer can print. It contains what's called PostScript code. And it is, like I said, vector, so it's individual vector design elements. If you open an EPS in Adobe Photoshop, what happens is it is rasterized, which means it converts that vector graphic into raster, into pixels. We would use EPSs for logos. In fact, back in the day, that was our standard for sharing a vector logo was an EPS. It always appears at the correct resolution. So to review, we talked about the raster graphics of a JPEG, a PNG, a TIFF, a GIF, and we talked about vector file formats, the PDF, the SVG, and the EPS. If you look out at any resource, you're going to find that there are hundreds of file types out there. If you just do a quick Google search, you'll find lists and lists. This is just a very brief list of raster graphic possibility types, and here's vector graphic file types. There are many, many more. The list every year continues to grow. So the conclusion here with file types is just know where you're headed. If you are developing something that will be printed, remember the best choices that may work in the print world. TIFFs might be the best for images intended to be printed. Web, think about what would be my best choice if I'm building this graphic for the web. That may be a PNG, a JPEG, a GIF, depending on what it is. You want to think about compressions. You want to think about quality, obviously. If you're going to be sharing, what's Mac and PC compatibility, basically, we really don't have limitations like we once did. So that should not be a concern. If you're doing logos, line art, in your mind, you should be thinking JPEG is the absolute worst choice. Do not use a JPEG for a logo. A better choice, it may be an SVG. It may be, depending on where it's going to go, if you're going to print it or if it's going to be on the web. So it's just thinking about where am I wanting this to be placed? What's the intention of what I'm creating? And now what's the best file type to utilize for this application? Remember, of native and non-native, always, always, always keep your native file format. If you develop something in Adobe Photoshop, keep the Photoshop file. You might have a JPEG that comes from that. You might have a TIFF that comes from that. Always keep the native file format. If you're working with a logo, always, always keep that Illustrator file, the native file, the .ai. It may be shared as an SVG, but always keep that native file format.